How are you, everyone? Good. It's so nice to see you guys again. I am. I thought I was doing well until a few hours ago. I started coughing a lot. So I don't know what's wrong. Probably because I was talking for 2 hours and my mouth is so dry. It could be that. So hard to get. Okay, so this week we have only class 3. And if you have any class on Tuesday, you're gonna have the Tuesday class. And then for the rest of the week, it's a mini vacation. So Tuesday, Wednesday, Thursday, Friday, there is no class. And if you have Saturday classes, then you have Saturday class, and then you're gonna have next week. Okay. So we are almost done in chapter 7. We did actually not almost done. We are halfway to chapter 7. Did you guys notice that I actually posted the review sheet for exam 1? Did? Cool. So for chapter 1 to 3, there is no math problem. It's all multiple choice, fill in the blank, all of those, except for draw histogram, something like that. And from chapter 4, 6, 7, 8, you have math problems in the exam. The question will be similar to the review sheet. So review sheet has more questions, more problems, and in the exam we're going to have less questions. Any question? Any comments? Concern? Complain? Nothing? Great. So in our last class, we talked about discrete random variable, and we said, well, to find the mean, all we have to do is multiply each variable, which is probability, and then we add on the end. The sum of the product is the mean, and for standard deviation, we have 2 ways of doing it. One of the methods is we subtract the mean from each observation. We square the observation so that the result becomes a positive number, and we multiply that with these probabilities. Once you get the sum of everything, it's a variance. Take the square root of the variance, it becomes standard deviation. The binomial random variable. We started binomial random variable, but we didn't finish it. So today we are going to finish it. Binomial, so bi means 2. Anytime you have 2 choices in your experiment, then we can use binomial. For example, flipping a coin, you only 2 outcomes, either head or tail. Just binomial. True false question, you only 2 choices. Either the question is true or it's false. So 2 choices, it's binomial. So anytime we have only 2 possible outcomes for the experiment, we can apply 1. And binomial has its own expected value. Sorry, mean means expected value, and also standard deviation. So sometimes they will give us the probability, like the random variable. For each variable, usually they give us the probability. But when they don't, we can figure this out by using Bernoulli formula. Bernoulli formula says first, pick how many success you're looking for in overall trials. So n choose R. And then multiply the probability of success to the power R. It means how many you want to get and what's the probability for each one of them. Then also multiply by 1 minus P, it means the failing rate, to the power n minus R. So we can find probability for each variable x using this formula. And when we have every number, every variable, the value for each variable, and then their individual probabilities, the mean is simple. It's number of trials times probability of success for each of them. So it's n times p, p is the success rate, and is the total number of trials. Standard deviation is NPQ with the square root. Q means 1 minus p. So you don't need the big chart, you don't need to you don't need to add anything, you don't need to do lots of work. All you have to do is find out the probability you're looking for, the success rate, and then how many you have, what's the number of trials you have, and then just multiply that. So we have two types of question here. Sometimes that's for probability. Let's say you are doing something, let's say you're flipping a coin 100 times. What is the probability that you're going to get 7 heads? So this simple question is easier with the binomial. We have 100 tiles, so it's M, and we are looking for 7 heads, so our R is 7. And our success rate for head is 1/2. Failure rate for head is also 1/2. So we can apply all the information in the probability formula, and we can easily find the probability. And if this is what is the mean number of heads you can obtain if you flip it 100 times, well, our N is 100, and the success rate to get it head is 1/2, so 50% chance. 50%, the mean is 50. Standard deviation is N times P times Q, so 1/2 times 1/2 times 100, take the step. So we can use it either for flipping a coin type of scenario, or we can do something like this one. When they actually give us some success rate for a different scenario. For example, here they are telling us that we have express checkout in a store, and then you're observing people. How many people are using the express checkout and how many are not? So our outcome are only 2 outcomes. Either people are using the express checkout or they're not using the express checkout. Seems to be only 2 possible outcomes, so we can solve this using binomial distribution. So binomial said, figure out all the information you need. So it says, what is the probability that at most 1 person used the express checkout from the 5 people we observed? So in a store, there are lots of people coming and going, and we observe only 5 of them randomly. And we have to see if among these 5 people, what's the probability that at most 1 person used the express checkout? You know, the funny thing, did you notice when you see something express with Godia, but in reality, the express has bigger line than the normal checkout. Did you notice that? I always do. And there was one video, a guy, he went to bank, it's a cartoon. He went to bank, did you guys see that? A guy, he went to bank, so it says express checkout and normal checkout. So that, oh, it's express checkout, let me go there. And then in front of him, there are lots of people. So like, well, even this express, but the other one is shorter, so let me go there. So he went there, and the express went really express. So they just call people one after another, so the line gets shorter. I was like, okay, then let me go there. And then he switches position again, and then becomes lazy again. And then the not express one got faster. They keep moving from one line to one line. At the end, 5 o'clock, clicked, and then they closed the bank. They could not able to see any teller. So that's the reality. Like whenever we see express, we go there. Or sometimes whenever we see something shorter, we try to go there. But in reality, the longer line goes faster than the shorter line. Many times it happens in life. Okay, anyway. So here we have to see how many of those people they use. What is the probability that at most 1 use the express checkout? So what is at most 1? Means how many people you are looking for? At most 1 means what? Either nobody used it or 1 person used it. So you're looking for what is the probability that no one used it, plus what is the probability that at least 1 person used it? I mean, 1 person. Okay. So at most mean either 0 or 1. Now, since it's a binomial, so we can use our formula. N choose R, success to the R, failure to the N minus R. So we have 20% people use the express checkout. What is this 20%? The failure rate or the success rate? Success, because we are looking for how many people used the express checkout. And we want to find how many, what's the probability that they used it. So this 20% gives us our P.20. In other words, 0.2. Okay, because you're looking for who used explicit out. If you're looking for who did not use explicit out, and they told us all 20% did not use explicit out, that means our P would have been 20%. So whatever we are looking for, our success is based on that. So if P is this one, what is our Q? How much? It's 1 minus P, right? So 1 minus 20% gives us 80%. Okay, so we have total N is 5. So in here, we have total 5 people. We want to see 0 people use from 5. So we are picking 0 from 5, not picking, choosing. We are choosing 0 from 5. Our success rate to the power 0, our failure rate to the power 5 minus 0, which is 5. So that's the probability for how many, what's the probability that nobody used that specific out. We are going to do the same thing here. We have total 5 people. We want to choose 1 from 5 and 0.2 to the power 1, 0.8 to the power 5 minus 1, which is 4. So whatever we have here, it always goes here to the success rate. And then we can simply use a calculator, figure out all the information. If you don't have the calculator, then you have to do everything manually. Okay? Since you guys have the calculator, tell me the answer. 0.73728, which is 73.73% total, right? Okay. So you found the probability for the first one and also probability for the second one? Great. Who is lost? No one. So you have to remember, you have to figure out how do you find and choose R in your calculator. Different calculator has different way of finding it. For example, let me show you normal calculator, the basic one. Does it have and choose R? Let me see. Graphing. Now, statistic. Data calculation. No. Oh, it doesn't have anything here. Man, it doesn't have statistic calculator. Graphing doesn't have any. How about programmer? Definitely not. Nope. Sorry. X to the Y. This is power. So we can do this power here, 2 to the power 0, 8 to the point 8 to the power 5. But N choose R. So if you don't have N choose R in the calculator, it's not a good calculator. Like this one. It doesn't have N choose R. How about function? No. Trigonometry, definitely not. Sorry, I can show you. So, yeah. Usually how it was in scientific calculator is you click 5 and then click the button NCR and then click whatever number you're looking for. For example, here, and then you click enter. Usually, okay, in most scientific calculator, you start with the N, click NCR, and then you click the other one. Here, manually. So N let me do it here on the next page. So N choose R. It has a formula N factorial, R factorial. And then we take the difference as factorial. So we are choosing 0 from 5. That means it's 5 factorial over 0 factorial. And then we do 5 minus 0, which is another 5 factorial. So 5 factorial cancel out. And what is 0 factorial? 1. So 5 choose 0 is 1. And we have 5 choose 1. It means 5 factorial over 1 factorial, and then 5 minus 1, which is 4 factorial. So we can write the numerator as 5 times 4 factorial, and then 4 factorial. 1 factorial is 1. So cancel this, we left it 5. But we definitely need calculator to figure out what is 0.8 to the power 5. So yeah, in the exam, you must need a calculator. Without calculator, you cannot pass the class. It's a fact. The formula says what is the probability that x equals 0? For binomial, to find the probability, this is the formula. To find probability for anything in a binomial distribution, you take n choose r, you multiply that by the probability of the success rate, and also multiply that with the probability of the failure rate to the power n minus r. That's the formula to find probability in a binomial scenario. Okay, you cannot use this for other scenario. Like you cannot use it for like say normal distribution. Normal distribution has its own rule, or discrete random variable. They have their own rule. This is only for binomial. So we have to find out the probability x is 0. That means from the 5 people, we are choosing 0 people. So n choose r means 5 choose 0. 5 choose 0. This is the formula. N factorial over r factorial, and then n minus r factorial. So you have two choices. Either use this formula and figure out your answer, or you use a calculator. Calculator has a built-in function for n choose r. But they don't write n and r this way. They write n, c, r. Once you get that, this is the success rate, because they told us that 20% people use express checkout. So our probability of success is 0.2. And whatever we have for p, it always has the power, whatever we are choosing. Okay?
No, the reason is because it says P on one, so that's why you try to create 1, 0.
At most 1 means either 1 or 0. Go ahead. Good. Okay, so depending on your question, what they're looking for, we use different variable, different number for our s. For example, the next one. Says what is the probability that at least 4% or 4 people use that festival? So the question is, what does at least 4 mean? At least 4 means 4 or more, right? So 4 or 5, 4 or more. So you're looking for what is the probability that x equals 4 and what is the probability that x equals 5. Because we have total 5 people to work with. So what do we write for the probability x equals 4? Who wants to try it? Go ahead. 5 choose 4. Failure rate.
Sorry?
Failure rate. So 0.2 to success. It's a trap. 5 minus 4. Okay, who would like to try the next one? Go ahead. 5 choose 5. 0.2 to the 5. 0.8 to the 0. Perfect. And now you punch your calculator and get the answer for both of them, and then you get the two. Do you already have the answer? Yeah. Are you lost? Tell me why do you get lost? When you see you have empty here, and it's yellow, and it's not to use this, but just to use ink color. So 5, and we are choosing what 4. So we have that. We have it's exactly right. So okay, so 5. Oh, you do twice. Yes. Wow. It's NCR supply shoes all. So if you want people to one kind of twice, same one, and then for tuning twice for picking features. That's because you can pick the first you have to pick a number. So 5 and now you're picking 4. Question. So for the last problem, can we go to so on the right side, actually 1, 5 about how do you get to something? I didn't get anywhere. He told me the answer. Okay, so what you do is this. Once you get this number, it's 1, and then whatever you have here, oh, this is 1 because anything to the power 0 is 1. And then the main thing is, what is this? 0.8 to the power 5. 0.328. And then here we know this is 5, this is 0.2, and what is 0.8 to the power 4? 0.41, anything else? 409. 409. Okay, so you add this plus that. But when you add this, first you need the multiplication here. And this is 1, not 2. My 1 always looks like 2. So do the same number? Yeah. So if you didn't have a calculator, you can't get to it. It's not, right? That's what I said. This class must need a calculator. Q is 1 minus P. So depending on what is your success rate, you fail, Q is the failure rate. So depending on the success rate, your Q will always be different. So when you flip a coin, our success rate for anything is 0.5, right? So our Q is also 1 minus 0.5, which is 0.5. So in that case, we have both same number. But Q, we don't know. We find it from the success rate. So who is the answer now? Do you have the answer, the true answer? 0.67%. 0.67%? That low? Or is 0. So is it 0.00? 0.0067? Really? Wow. Hmm? Yeah, I don't know. Do you have the answer? You can use the one. Actually, one has the scientific one has.
Because I use that for the cookies.
Yes.
I don't say there's that.
How do you get 6?
It's
Only
that
6? 6 for which one? For 5 choose 4 or 5 choose 5?
in total.
Oh, so in total you have only 6.
Using that.
But this is only for choosing, for this part only. Once you get this part using this formula, you have to multiply these and multiply that. And then plus use the formula to get this, but multiply this and multiply that. And 6 cannot be answered because probability always lies between which two numbers? 0 and 1. If 6 is above 1, so it cannot be a 12. So this point gives us 5, right? 5 choose 4 gives us 5. Okay. So we have 5. What is 0.2 to the power 4? That's why nobody say. What is 0.2 to the power 4? 0.2 times 0.2 times 1.6? No. 0.00616. Right? 0.0016. And then we have 0.8. 5 choose 1, 5 choose 5 is 1. And 0.2 to the 5, 0.00032. Right? If I'm not wrong. And this is 1. So if we add this, yep, the answer is very small. 0.0067, that gives us 0.67%. Not even 1%. 0.67, man. So definitely 4 or more people, they don't use that out. They're smart. The next one, what's the probability? Exactly 3 use that out. And exactly 3 did not use that out. Probability x is 3. And how do you find the probability? 5 choose 3. 0.0592. 12. So 5.12% chance. 5.12% probability that exactly 3. 5% only? It's very low. And what did we get for the first one? 73%. That at most one, oh, it means not many people actually use express checkout. For the first one, at most one uses 73. The more we go, the less we get. For exactly 3 is 5, more 4 or more points. 671. What do you think about the last one? Exactly 3 did not use express checkout. You can do it many ways. And say 0, 1, 2. Think about logical. You have 5 people. What's the probability that exactly 3 did not use? 2.
Can you find like the probability of two that use it and then subtract it?
If you just find the 2, it's fine. Because exactly 3 did not use means how many used? 2.
Would another way be to do it for kids? Like switch them? I mean,
P and Q. So that's what I said. You can do it many ways. So method 1. 3 did not use means 2 used, right? So we can find what's the probability x equals 2. Method 2. Since we are looking for did not use, that means we are looking at failure rate. So P is failure rate instead of success rate, which is 0.8. So we are thinking from 5, 3 people did not use. So 0.8 to the 3 and 0.2 to the 2. This is 5 pick 2, 0.2 to the 2, 0.8 to the 3. Right? Is something else? Or 3 people did not use mean 5 choose 3, 0.8 to the 3, 0.2 squared. Yep, that's it. That means 5 choose 2 and 5 choose 3. They're supposed to give us the same number. Do they? No? Then what did they do wrong?
oh wait, look at them.
5 choose 3, 5 choose 2. 5 factorial, 3 factorial, 5 minus 3, 2 factorial. They are same. 5 factorial, 2 factorial, 5 minus 2, 3 factorial. Huh? Because we don't have 6 people. We have only 5 people. So 3 did not use, definitely means how many used? 2, right? Oh, does the complement work? I think the complement doesn't work here. Because 3 did not use, it means 1 minus did use. 1 minus, does it work? Did you work with complement?
I was just
Yeah.
curious.
Okay, let's see, does the complement work? So 1 minus how many used, right? 3 did not use means 1 minus did use. So 1 minus 3 used. So 1 minus probability x equals 3. 1 minus 5 choose 3. 0.2 to the 3. 0.8 to the 2. So what do we have for any of those? What's the number? Did you guys solve it? What do you have? 0.2048. So 1 minus 0.2048 doesn't give us the same answer, right? Oh, no, sorry, I'm looking at the other way around. Okay, so this is 0.20, but here we have to find this new way. We are looking at n 5 choose 3, 2 to the 3, and 8 to the 2. So how much is this? Same thing? It shouldn't be same because 5 choose 2, 0.2 to the 3, 0.2 squared, 0.8 to the cube give us this much. But here we switch the position, so I can see they're different. So how much you have? 0.7952. That will give us 0.2, right? Oh yeah, complement does work. So it did not need 6 people. You are still. So see, 3 different methods. Method 3. So you can answer same question in any of the 3 ways. Who is unclear about anything? Who is lost? Anyone? No? This is from the homework. So you're going to see similar question in the homework. But the question what you're going to see in the exam is the next one, I think. Can I flip my page? Okay. We are flipping it here on 4 times. In the exam, I'm not going to give you 4 times, I'm going to give you a big number, like 40 or 400. So that we cannot actually use the tree diagram. So we are flipping if we are going 4 times. What's the probability that we are going to get exactly 3 heads? Let's say you're doing it for 40 times, okay? Just in case. We are flipping if we are going 40 times. There are 40 trials. What is the probability that in all these 40 trials, we have exactly 3 times heads, 3 heads, sorry. Exactly 3 heads. So head, our event is getting heads, right? So probability of success, it means finding probability of head, right? Because you're looking for head, so anytime we get head, it's a success. So what is the probability of head? 1/2. It doesn't matter how many times you do it, for 1 time it's always 1. Now, what is our n here? Means how many times we are doing the same thing again and again and again and again. 40. I changed the 4 into 40, okay? Okay, so n is 40, our p is 1/2. And when we do this experiment, how many possible outcomes we get? Is it 1 outcome, 2 outcomes, 3 outcomes, 4 outcomes? What is our maximum number of outcomes we can get in this experiment? When you do it once, 2 outcomes, right? So whenever we have only 2 outcomes, what type of distribution we can use? Binomial. So that's how we decide when to use binomial and when not to. This is the best example of the binomial because we have always 2 outcomes for any trial. So if our P is 0.5, what is our Q? Same thing, 1 minus P, which is 1 minus 1/2, which is another 1/2. Now they want us to find exactly 3 heads. Means probability of x equals 3. So what's the formula? We are choosing what from what? And choose R, right? And choose R, P to the R, Q to the N minus R. So what would be our formula here? What choose what? We have 40 trials. In these 40 trials, we are looking for only 3 types. When do we have 3 heads? Probability of head is half. That gets the R. Probability of failure is also 1/2. That gets 40 minus 3. So when you combine these, we actually get 1/2 to the 40. So you don't have to do it twice. It's simply 1/2 to the 40. You may wonder why. Let me show you why. 1/2 to the 3 and 1/2 to the 40 minus 3 is 37, right? In multiplication, if you have the same base, the rule says what to do. Keep the base at the power. So 1/2 to the power 40. That means all you have to know is what is 4 choose 3. Sorry, 40 choose 3. So how much is 40 choose 3? 9880. So we have 9880, and you can simply divide 2 to the 40 if you want. Because 1/2 to the 40 means is divided by 2 to the 40. So what do we have? We should be a very small number. 0 point. How many zeros we have? 10 to the negative 8, and then what's the number we have?
Oh, actually,
898. Yeah. So it's actually 1, 2, 3, 4, 5, 6, 7, 8, 8 zeros, and then 898. It's a very, very small chance. When you flip it for 40 times, exactly 3 head, rarely happens. Not likely. See, this type of question is fun. So in the exam, you're going to see this type of question. And when I don't mention round to what decimal places, round till how many you see a number. Okay? So don't write 0. Write 0, 0, 0, 0 until you see something. Right. You can. Whatever, it's fine. Either this or that. Okay, try the next one. What is the probability that at least one tail you are going to get when you roll it short, sorry, when you flip it for 40 times? What does at least one mean? Hmm? 0 and 1? No, at least once. At least one means one or more. That means it definitely cannot add all this probability. 1 to 40. So how else we can find this probability? You can, but you can actually find it even easier way. Because even if you summation, unless you have a graphing calculator or something, you cannot do it. You have to find the sum 40 times. Complement. So see, complement is helpful here. Complement. So at least one tail. What is this complement? 1 minus what? No tail. And what does no tail mean? How many heads? If you have no tail, so how many heads you are having? All 40, right? So you have two ways of finding it. Either find what the probability of no tail by finding no tail, or if you don't understand how to find no tail, you can simply write 40 heads. No tail means actually 0 tail. So you can find 1 minus probability of 0 tail. Since head and tail, they both have the same success rate, so either one will be the same answer. But if they do not have the same success rate, then we cannot use same thing. Okay. So I'll show both. 1 minus probability of x is 40, means 1 minus, we are choosing 40 from 40. 1/2 to the 40, 1/2 to the 0. 40 to 0, I bet it's 1. And this is also 1. So you have 1 minus 1 over 2 to the 40. In other words, it's 2 to the 39. No, I could be wrong. I don't want to be. And then 49. Is it 2 to the 1 over 2 to the 39? I don't know. So whatever that is. Huh? 1? The whole thing is 1? Yeah, because 2 to the 40 is a very, very small number. But dividing by small makes it bigger. Are you sure it's 1? Let's see the calculator. 1 minus 1 over 2 to the power 40. Close it. Oh yeah, it is 1. 0.99999, which is, why it doesn't make sense? So 1 over 4, 2 to the 40 is too big, as a result it's too small and here. Math-wise it makes sense, but common sense-wise it doesn't make sense. What is the, oh, at least one tail, maybe 1 or more tail, makes sense. Yeah. I was thinking it's a probability for 40 and it's 1, but possible. So yeah, it does make sense. Probability that we are going to get definitely 1 or more tail is almost certain. When you flip it for 40 times, definitely at least 1 you're going to get tail. I would say very unlikely. That's 6.99999. Huh? Exactly. If you want to get that, you'll like it. But if you're looking for tail, you're very unlikely. Okay, any question? No. So that's how we apply the formula to get the probability for any binomial scenario. Oh, this is for 4, okay? For when you roll it for, when you flip it 4 times. So this is the story for when you flip it 4 times. But we change 4 into 40, our story is different. Now, how do you find the mean? So you flip it for 40 times. Now you have to find the mean. What is the average number of time you get head or you get tail? Okay. So to find the mean, all you have to do is multiply number of trials times the probability of success. For example, here we have x represent number of heads, and we are flipping it for 16 times. What is the mean heads and standard deviation for the head? So you're flipping it for 16 times. We want to see the average times we get head. Since it's a binomial scenario, so before even finding mean, first you have to ask yourself, this scenario, is it a binomial? It's not a binomial. If you find it's a binomial scenario, that means your life is easy. Your mean is just multiplication. If it's not a binomial, then you have to ask yourself, what type of scenario we have? Because depending on different distribution, we have different formulas. Let's say in the exam we see this question, and obviously we will not know it is from from binomial. You may not know, okay? So you ask yourself, well, when you find the head, that means you're flipping a coin. When you flip a coin, what is the total number of possible outcomes we have? 2. That means a binomial. So binomial means just multiply. The mean is m times p. How many times you're flipping our coin? What is the probability of getting a head? 1/2. What is half of 16? 8. That means if you flip it for 16 times, there's average 8 times we get head. Now standard deviation says square root of NPQ. So 16 times half times another half. Basically, we know this is 8. Half of 8 is 4. Square root of 4 is 2. It's 8. It looks weird.
You have to write it out as plus or minus two or just
So here is the algebra. When you work with a variable, okay? So if I ask you x4 equals 4, what is x? It means I don't know what is x. So I'm asking you, what number square will give you 4? So what answer you're going to give me? 2. Only 2? See, we don't know what is this x. So we have 2 choices. Either it's 2 or it's -2. But here, do we have something that you don't know? Do you have any variable here? Any x here? No. We're simply finding square root of 4. So what is square root of 4? Only 2. I did not ask you what number square is 4. I asked you what is square root of 4. The square root of 4 is 2. But when you don't know something, you have 2 choices. But when you do know just the numbers, it's a positive number. Okay? So anytime you're finding the square root of any number without any variable, the answer is always positive. Okay, so we are done with binomial distribution. Now comes normal distribution. So any question on binomial distribution? Any question at all? Was anything unclear, confusing? So don't forget to start doing your homework on chapter 7 if you're done in chapter 6. Or even if you're not done in chapter 6, no problem. Do them simultaneously at the same time. Question? No? Okay, so for normal distribution, I'm going to show you a video. Can I flip my page? Ready? Okay. Instead of going through all the details myself, let's see. Come on. Let's see. It's a 6 minutes video.
This video, we'll be learning about test scores and standardization.
That means Z.
Learn how to calculate exact proportions using standard normal distribution. What is the standard normal distribution? The standard normal distribution is a special type of normal distribution that has a mean of 0 and a standard deviation of 1. Because of this, the standard normal distribution is always centered at 0 and has intervals that increase by 1. Each number on the horizontal axis corresponds to a z-score. A z-score tells us how many standard deviations and observations from the mean. For example, a z-score of -2 tells me that I am 2 standard deviations to the left, and a z-score of 1.5 tells me that I am 1.5 standard deviations to the right of me. Most importantly, a z-score allows us to calculate how much area that specific z-score is associated, and we can find out that exact area using something called the z-score table, also known as standard normal table. This table tells us the total amount of area contained to the left side of any value of z. For this table, the top row and first column correspond to z values, and all the numbers in the middle correspond to areas. For example, according to the table, a z-score of -1.5 has an area of 0.0256 to the left of it. To say this in a more formal manner, we can say that the proportion of z less than -1.5 is equal to 0.0256.
Lacey,
We can also use the standard normal table
Yasmin,
to determine the area to the right.
Ryan absent,
All we have to
Jenny,
do is take 1 minus the area that corresponds to the
Anton,
value. For example, to determine the area to
Christina,
the right, let's go to 7,
Luigi,
all we have to do is find the area that corresponds to
Christopher,
the value and subtract 1.
Christopher,
According to the table, the z-score of 0.7 has
Jacob,
an area of 0.7157 to the left of it. So 1 minus 0.7157
Rami,
gives us an area of 0.284.
Jamina
And that is our
absent,
answer. The
Waiting,
reason why we can do this is because we have to remember that
Waiting.
normal density and it
Xian,
always has a total area equal to 1%.
How,
We can also
Lila,
use the z-score table to do a reverse look,
Lila,
which means we use the table to see what z-score is
Jason
associated
Liu,
with the area. So if I wanted to know what value of
Yusuf,
z corresponds to an area of
Isabella,
0.8461 to the left, all we have to do is find
Nithya,
0.8461 on the table
Kevin,
and see what value of z it corresponds to. We see that it corresponds
Salma,
to a z value of 1.02.
he's
The
here,
special thing about the standard
Karina,
distribution is that any type of normal distribution can be transformed into it. In other words,
Mariah,
any normal distribution with any value of
Mia,
sigma can be transformed into the standard normal distribution where
Tahmina,
we have 0 and standard deviation 1.
Wendy,
This conversion process is called standardization.
Sebastian,
The benefit of standardization is that it allows us
Fatima,
to use the z-score table to calculate the exact areas for any given
Abhinav,
normal population with any value of
Weedy,
sigma. Standardization
Jason
involves
Ju,
formula. This formula says that the z-score is equal to an observation x minus the population mean divided by the population standard deviation sigma. So suppose that we gathered data from last year's biochemistry exam and found that it followed a normal distribution with a mean of 60 and a standard deviation of 10. If we were to draw this normal distribution, we would have 60 located at the center of the distribution because it is the value of the mean. And each interval would increase by 10 since that is the value of the standard deviation. To convert this distribution to the standard normal distribution, we will use the formula. The value of mu is equal to 60 and the value of sigma is equal to 10. We can then take each value of x and plug it into the equation. If I plug in 60, I will get a value of 0. If I plug in 50, I will get a value of -1. If I plug in 40, I will get a value of -2. If we do this for each value, you can see that we end up with the same values as the standard normal distribution. When doing this conversion process, the mean of the normal distribution will always be converted to 0, and the standard deviation will always correspond to a value of 1. It's important to remember that this will happen with any normal distribution, no matter what value the mean sigma are. Now, if I ask you what proportion of students scored less than 49 on the exam, it is this area that we are interested in. However, the proportion of x less than 49 is unknown until we use the standardization formula. After plugging in 49 into this formula, we end up with a value of -1.1. As a result, we will be looking for the proportion of z less than -1.1. And finally, we can use the z-score table to determine how much area is associated with the z-score. According to the table, there's an area of 0.1357 to the left of the z value. This means that the proportion of z less than -1.1 is 0.1357. This value is in fact the same proportion of individuals that scored less than 49 on the exam. As a result, yeah. Let's do one more example. When measuring the height of all students at a local university, it was found that it was normally distributed with a mean height of 5.5 feet and a standard deviation of 0.5 feet. What proportion of students are between 5.81 feet and 6.3 feet tall? Before we solve this question, it's always a good habit to first write down important information. So we have a mean of 5.5 feet and a sigma of 0.5. We are also looking for the proportion of individuals between 5.81 feet and 6.3 feet tall. This corresponds to this highlighted area. To determine this area, we need to standardize the distribution. So we will use the standardization formula. Plugging in 5.81 to this formula gives us a z-score of 0.62. And plugging in 6.3 into the formula gives us a z-score of 1.6. According to the standard normal table, the z-score of 0.62 corresponds to an area of 0.7324, and the z-score of 1.6 corresponds to an area of 0.9452. To find the proportion of values between 0.62 and 1.6, we must subtract the smaller area from the bigger area. So 0.9452 minus 0.7324 gives us 0.2128. As a result, the proportion of students between 5.81 feet and 6.3 feet tall is 0.2128. If you found this video helpful, consider supporting us on Patreon to help us make more videos. You can also visit our website, simplearningpro.com.
So that's the story behind normal distribution. We like to have normal distribution because we have a table of probabilities that you can find easily without doing any math. Okay? That's whenever we have any type of distribution, we want any type of distribution, our goal is to convert it to normal distribution. And when you have normal distribution, our goal is to convert it to standard normal distribution. Standard normal distribution means we have mean exactly 1 and standard deviation 0. Or the other way around. Mean is 0, standard deviation is 1. Okay? So the way we write is x if we do line and mu sigma. It means we have a random variable x that has normal distribution with the mean, mu, and standard deviation sigma. That's how we use it. So what is the normal distribution stat? Well, the probability function that specifies how the values of a variable are distributed is called the normal distribution. It's symmetric since most of the observations assemble around the central peak of the curve, and the probabilities for values of the distribution are distance from the mean narrow off evenly in both directions. It means we have this shape, the normal shape. We have exactly in the middle, we have our mean. And on the both sides, the more you are going far from the mean, the numbers are going down because you are going away from the mean by standard deviation. For example, here is 1 standard deviation. Here on the left side, -1 standard deviation. And then if you go more farther, it's 2 standard deviation on the top, on the upper side, 2 standard deviation on the lower side. So the more you go from the mean, the less and less you go from, the less and less number you get. What's the normal distribution we used for? The normal distribution is significant in statistic and is often used to in the natural science and social science, social arts, to describe real valued random variable whose distributions are unknown. So anytime we have any type of distribution, you have no idea what type of distribution, we are to convert into normal distribution so that we have some idea what is going on in this data set, in this distribution. How do we know if data is normally distributed or not? Well, easy. You plot them, you draw the histogram, and if it has a bell-shaped curve, it means a normal distribution. These are the myths. What are the properties? Normal distribution is completely determined by the mean and standard deviation. So in normal distribution, there are only 2 things we need. That's it. We don't need any other information. What is the mean and what is the standard deviation? Normal distribution is symmetric about the mean, and in the mean, we have mean equals median equals mode. All 3 things are same because it has symmetric shape. So here we have mean equals median equals mode. All 3M are same. The total area under the curve is 1, because remember, the area we get under the curve, each of them they represent probability. And when you add all the probabilities, what is the sum of all the probabilities? 1. Since the sum of all the probabilities is 1, that means the area we have under the curve, the bell curve, the sum is 1. The curve never touches or crosses the x-axis. So it's always above the x-axis. It gets very close to the x-axis, but it cannot cross the x-axis. It cannot touch that. And to find little area for every piece, we use empirical rule. It means if you go 1 standard deviation on the left and right, you already have 16% of the data set within this area. If you go 2 standard deviation on the left and right, you have at least 95% information in that area. When you go 3 standard deviation, basically you have almost 99.7% information in that area. So when you go 3 standard deviation, mostly we have all the information we need. Also, all the data set we have, we need in our, all the data set we have in our data set, all the information we have in our data set. Okay, we've seen this before. So it's just the picture from before. 1 standard deviation on the below side means 34% on the downside. 1 standard deviation above means 34% on the above side. And then the more you go, the more tiny pieces you add. When you add all of them, you get 99.7. It's 100 because we still have some peak on the left side here and some peak on the right side. So when you add everything, then it will be add up to 1. Otherwise, from 3 standard deviation on the left, 3 standard deviation on the right, we have 99.7% information. Okay, we can stop here. In our next class, we are gonna work with Z-score, like what they did in the table. Sorry, what they did in the video. Whenever we have any type of information, how do we figure it out by converting them to notes? Oh, Wednesday we have the class. See you all after 1 week. Chapter 1 to chapter 8 to 5. So 7 chapters.